Welcome back, dear viewers, and we're back at our Starklings Learning Cairo initiative for non-tech background. So we are on primitive type 1, so we need to read here the data types. Fill in the rest of the line that has code missing, no hints, no tricks. Just get to use this typing. So booleans, f and main. So this is the when writing Cairo language, this is the first entry point. Booleans. So booleans is a possible value, true and false. R1 felt 252 in size. The boolean type in Cairo is using bool. Let T true, let F bool if false with explicit type annotation. When declaring a bool, mandatory to use true or false as value. Hence, it is not allowed to use integer, example in 0 instead of false for bool this declaration. So we have booleans here. Let is underscore morning true. If is underscore morning, print good morning. Let finish the rest of this line like the example or make it be a false. If is underscore evening, good evening. So is underscore evening because it's evening here, true. Let's see if it compiled true or maybe false. Okay. So it's here true. Boolean said mandatory to use true or false. So the other is true. Maybe this one is false. False. Compile. So false. This one, you need a semicolon. Same as this one. Means that it is ending and we are ready for the next code. Semicolon. Perfect. So the next. Primitive type 2, fill in the rest of the line that has a code missing, no hints, no tricks. Just get to use to this typing. No hint. Show here, let's see. A short string is a string whose length is as most 31 characters and therefore can fit into a single field element. Short strings are actually thoughts. They are not real string. Note the single quotes that are used with short strings. So here, string. Cairo doesn't have a native type of string, but provides two ways to handle them. Short string using simple quotes and byte array. So short string is here. For example, A is equivalent to 0x61, B 62C, and this equivalent to ABC. Oh, okay. A short string is limited to 31 characters. 31 times 8 is equals to 200, maximum multiple of 8 that fits in 251 bits. ABC. And the bytes array string. Okay. Let mute. Finish let and mute. My first initial equals to C. If alphabetic is reference my first initial C. Print alphabetical. This one. Else is numeric. Reference my first initial. Print numerical. Print neither alphabet nor numeric. Let finish this line like the example. What's your favorite short string? Try a letter, try a number, try a special, try a short string. Note, the following code is not part of the challenge. Just here to make the code above work. Direct felt 252 comparable from the core, so we need to implement them ourselves. Ah, okay. So it's my head's getting crazy right now. So this one, we need to finish this one. It says let mute. Okay. Let mute your character is equals to SMPH. Character. Okay, compile. Numeric. Your character print numerical, else print neither alphabet nor numeric. Okay, it compiles. Okay. Wow. Primitive types 3. Destructure the cat tuple to call print on each member. So hint, you need to make a pattern to bind name and age to the appropriate part of the tuple. Tuple. So tuple is a general way of grouping together a number of values with a variety of types into one compound. So it has a fixed length. Once declared, they cannot grow or shrink in size. So this one, we will write a comma. So our short string here is Furry McPherson. This is the felt 252 and 3. This is the felt 252. So basically, we need to have a structure to call the print name and age. So what we need to do is maybe put the name here, let name, and the age of the cat equals to the cat name and age cat. So if you call the name, it will put the name Furry McPherson and the age of Furry McPherson. That's it. So let's try to compile. So I'm not familiar with Rust. Okay, it compiled. So next, primitive 4. Modify the integer type to make the test pass. Learn how to convert between integer types and felts. So integer is here. So scalar types represent a single value. Cairo has 3, felt, integer, and boolean. So the felt is a filled element, felt 252. Integer is a fundamental type that serves as basis for creating types of the core library. So 8-bit, the unsigned is U8, 16-bit, U16, and so on and so forth. So let's, in here, it says to do modify the type of this function to prevent an overflow when summing big values. To do modify, don't modify the value, just the types. See how using the U8 suffix on the numbers let us specify the type. Try to do the same thing with other integers. If you try to sum two integers and the result is bigger than the biggest integer of this type, you'll get, you can convert integer to felts using the dot into method. You can convert felts to integer using the try integers to into. So sum u8 and u8 equals to x plus y. To do, modify the type of this function to prevent an overflow when summing big values. Convert to felt. Convert in convert felts using that into try underscore into felt convert x as a u8. Okay, u8 is integers. Try into, so it doesn't work. Maybe we will some big numbers try to use u64 u64 and in here to do modify this test to use the correct integer types. Don't modify the value, just the types u64 4. Let's try to test. Convert to felt. Convert the felt to u8. So in here, in order to convert, we need to put into method integers into method x in here try into x. So let's try to test it. Unexpected return found option to do return as u8 here. Let's try to dot unwrap. Okay, we need to unwrap it. This is the try into conversion. Try into. We need to unwrap. That's why need to unwrap it. And for the into, just need this one. And that's it for the primitive type into call, the type conversion methods. You can read it whole here so that you can answer primitives as well, data type.